Hi everyone, in this lesson we're going to be looking at trigonometric functions. And we have some vocabulary. A radian is a unit of measure for all angles. 1 radian is the angle made at the center of a circle by an arc whose length is equal to the radius of the circle. So all of these measures are the same. When that happens, we have 1 radian. And sometimes you'll be required to convert from degrees to radians or from radians to degrees. If you're going from radians to degrees, you multiply by 180 over pi, and if it's degrees to radians, you're going to multiply by pi over 180. The abbreviation RAD is used for radians, but it's often omitted, particularly when pi is present. So we're always going to assume, and this is very important, we're always going to assume we're in radians if we don't see a degree symbol. You are to assume that if there's no degree symbol, we are in radians. So it says convert 56.5 degrees to radians. Since we're converting to radians, we're going to multiply by pi over 180. When we do that, we're going to get 0.986 radians. So if I don't write anything, we assume radians. You could write just RAD, you could leave it blank, or you could actually write out the word radians. Typically though, like I said, we just don't put anything there. We assume it's radians. Now we're converting from radians to degrees, and typically radians, you'll have a pi symbol in it, but not always. So since we're converting to degrees, we're going to be multiplying by 180 over pi. When we do that, we'll get 240 degrees. So on this page, we have more vocabulary. Most of it, hopefully you remember from your geometry days. I think the pictures I have here should be really helpful. We have an arc, that's the part of the circumference of a circle. We have a minor arc, that would be the shortest distance between points, 2 points like A and B, or a major arc, which is going to be the longest distance between A and B. A sector is a region enclosed by 2 radii and an arc. A chord is the line segment joining 2 points on the circumference of the circle. And notice a chord doesn't necessarily go through the center of the circle. And a segment is the region between a chord and an arc. So here we have a segment. Now in the formula booklet, I always like to remind you, you should have your formula booklet handy at all times. If you go to topic 3 for geometry and trigonometry, SL 3.4, they give you the formula for the length of the arc and the formula for the area of a sector. Very, very little things have to be memorized for the IB exam. So for example 2, it says find the arc length and leave the answer in terms of pi. So the formula for the arc length is L equals R theta. Right? L represents the arc length. In this case, the radius is 8 and the angle is 3 pi over 4. When we simplify that, we get that the arc is equal to 6 pi centimeters. Don't forget to include your units. Find the area of the sector of the circle and leave the answer in terms of pi. First, we'll write the formula for the area of a sector as it's provided in the formula booklet. Okay, the radius is 8. The angle is 3 pi over 4. Simplify that, leaving it in terms of pi, we get the area is equal to 24 pi centimeters. Simplifying that, we get 24 pi centimeters squared. Remember, when we're looking at area, we're going to have units squared. Right, the last one is more a better example of what you might see on an IB exam. It says find the shaded area, round to the nearest tenth. And I always like to write out in words what I want to do here. So I want to find the area of the shaded part. So I have this area of the sector, this whole piece here, all the way here. This is the area of the sector. And I have to subtract out the area of this triangle in order to get that shaded area. So let me write that out. The formula for the area of a sector is 1/2 r squared theta. The formula for the area of a triangle. Now, there's two formulas that we know of for the area of a triangle. There's 1/2 base times height, and there's also the 1/2 AB sine C formula that we've recently learned that you could also use. So since we have the two sides and the included angle, we have 6, 6, and the included angle, I'm going to use the formula that we learned recently. And again, that is in your formula booklet. Let's write it out. So this means that we're using the two sides and the included angle. So we have the two sides and the angle between them. Right, so let's go ahead and fill that in. So since we want to note that we are in radians, we need to make sure the calculator is in radian mode. Right now you can see at the top of my screen, it says degree mode. At the top of your calculator, if you have a newest model, you'll see what mode you're in. If you're not sure, we're going to go, and I have to change it anyway, so we're going to press the mode button. It's highlighted in red right now on the screen. And we're going to scroll down, and we're going to highlight radians and hit enter. And now we're in radian mode, and you can see it changed at the top of my screen. And then we're just going to quit out of here. And then we can do the calculation for the problem. When we do the calculation, we get 22.1 centimeters squared. Okay, everyone, that's all I have for this lesson. Thanks for watching.